Sample final, the first problem. I'm going to have a series of terms, and each of these is a ratio. You're best off doing some dividing and conquering. So instead of looking at the entire ratio, just look at the numerator, try to spot a pattern. Look at the denominator, again, try to spot a pattern. For the numerator, I see a gap of 2 between each of them. In the denominator, it looks like each time it's doubling. Now, spotting the pattern is just the first hurdle. Next, what you have to do is find a way to describe that pattern. Now, I like specifying whether the first term is going to be a sub 0 or a sub 1. In this case, if I make it a sub 1, treating this as the first term, then I know that my numerator must be 2 times n plus something. If you do it the books method is to find the difference. That will be 2. Multiply that by n minus 1, and then add the first term. That's a mechanical way of handling this type of arithmetic sequence. Personally, I find it as easy to say that each time is doubling, so that's 2n, and for my first term, if I plug in 1, that would give me 2. That's 1 too many, so I would just write 2n minus 1. Either of these two is an acceptable way of characterizing the numerator. The denominator is times 2. Again, the books method is to take the first term, whatever it is, in this case 2, and to multiply it by the ratio to the n minus 1. I would be happy just saying that this is something like 2 to the n. If I take my first term, that would be 2 to the first is 2. It happens to match. So I would have written it this way. Now, this and this are clearly equivalent. Either will be acceptable. Part B. There are actually 3 things going on here. First, there's the numerator. Second, the denominator. Third is going to be the change in sign, plus, minus, plus, minus. I tend to handle those 3 things separately. I spot that the top, once again, is arithmetic, and the difference is just 1. I would probably write n plus 4. This is treating the first term as a sub 1. If you follow the books method, it would be the difference, which is 1, times n minus 1, plus the first term, which would be 5. Now, if I expand, gather like terms together, this equals that. Either is acceptable. For the denominator, 6 doubled is 12, doubled is 24, doubled is 48. So the pattern is 2 to the n, as it was up here. This time, when I put in 2 to the n, I'm not getting the right starting point. If this is my first term, then 2 to the first is 2. I would need to multiply by 3. This is how I would tend to write it. For the book, remember that it is the first term times 2 to the n minus 1. That's if you start with the first term. If you had started with the 0th term, it just would have been first term times 2 to the n. And this turns out to be equal to this. Lastly, the alternating sign. Alternating sign is going to be either -1 to the nth or -1 to the n plus 1. And I'll make that decision based on wanting to start positive and then turn negative. If my first term is a sub 1, then -1 to the nth would be -1, not positive. That gives me reason to think that I want this term, -1 to the n plus 1. So any odd number that I plug in, when I add 1 will become even. -1 to an even power will be positive. So the first, third, fifth will be positive. If I plug in an even number, then an even number plus 1 is an odd number. -1 to an odd power is negative. So for the evens, for 2, 4, and 6, for the second, fourth, and sixth terms, I would have a negative. Either of these two answers is acceptable.